This is the second of the hopefully three maybe videos that will explain how to do the problems on page 155. Solutions, we've already done problem numbers 9, 10, 11, and here we have number 17. This one actually is a pretty quick one. So again, keeping with the theme of taking the derivative of both sides with respect to x in our quest to find the dy dx. The dx dx on the left-hand side is just 1. The derivative of the tangent of anything is the secant squared of that anything, but we have to multiply by the derivative of that anything. So it's secant squared y prime. And then if we divide both sides by the secant squared of y, we can leave it as 1 over secant squared of y, or if we want to, we can write it as y prime equals the cosine squared of y. Either one is totally fine. That's it. That's number 17. Number 18, once we get trig in there, it tends to simplify things a little bit for us. Hopefully you're feeling the same thing. The derivative of the left side with respect to x is the derivative of x with respect to x. And so let's do that first. Let's break it down just to remind you of what you're supposed to be doing. The derivative of the sum of two functions is the sum of their derivatives. And the derivative of the right side, by the way, is 0. Derivative of 0 is 0. And so we can break it down. Derivative of x with respect to x is just 1. The derivative of the tangent of something is the secant squared of that something. And we've already talked about that. But we have to multiply by the derivative of that something. And the derivative of xy, we can see the derivative of a product, and we know that the derivative of a product is not the product of the derivatives, but we have to use the product rule. So we have 1 plus the secant squared of xy, multiplied by, again, the derivative of xy, which would be the first function times the derivative of the second, plus the second function. You know what? Plus the second function multiplied by the derivative of the first, which is 1. You get 0. Okay. Well, I noticed that I have a y prime in here, and the other day it seemed to work a little bit better when we didn't distribute that, so I'm not going to make you distribute that. I'll just kind of go along with what you guys like better. And we have the secant squared of xy multiplied by the xy prime plus y equals -1. So I subtracted 1 from both sides. That allows me to divide both sides by the secant squared of xy. So we're going to divide by both sides by the secant squared of xy. Okay, and then we're going to free up that xy prime. So here we have our secant squareds canceling out, and I get xy prime plus y equaling -1 over secant squared of xy. I'm running out of room a little bit here, so let's go ahead and subtract y from both sides. Subtract y. And at the same time, can we squeeze it in here? Yeah, I guess we won't do it at the same time. We have xy prime equaling -1 over secant squared of xy minus y, and we're going to divide both sides by x. Okay, so if we divide both sides by x, then it's just like multiplying both sides by 1 over x. And so if you multiply both sides by 1 over x, this first term gets a 1 over x times that, and then the second term gets a 1 over x times that. And that way I can squeeze it all in here, and this whole thing right here, -1 over, you know what, I'll put it up on the top, and I'll put it up in the right-hand corner here. Okay, so the final answer is y prime equals -1 over x times the secant squared of xy minus y over x. I thought we did that one in class. Maybe we did. Nevertheless, there it is. That's number 19. Okay, let's see if I can squeeze number 20 in here as well. So number 20, the derivative of both sides with respect to x. I hear students getting ready to walk in, so I got to get this going here. You know what? I do hear students coming in, so it's the end of class. I'm doing this on my break, and I will pick it up in the next video.